This video is all about the transformations of graphs. You should be familiar with all of the graphs on the screen right now, either from this year. We've covered all of these ones on the left-hand side in year 12 so far, or all of the ones on the right-hand side over here, where you've either covered them in GCSE, or we're going to cover them in a lot more detail later on this year. But you should have a rough idea of all of these shapes based on the equations. What we're going to look at today is how we can tweak the equations slightly and get whole new graphs. And if we understand the effect of those tweaks, it can be really, really powerful and really helpful. So when I say tweaks, there's 6 you need to know. Here is a summary of all of them. So press pause while you copy those down into your video notes. Now I'm going to show you examples of all of those, just to make it visually clear what's going on. So here is the first one. The function I'm going to use to demonstrate the first couple of transformations is x squared. So what I'm saying here is that this is my f of x function. And so here I've got f of x plus a. At the moment you can see that a is going to be set to be 1, and then we're going to see what effect that has as I change the value of a. So let's have a look at the graph when it is 1. So we can see in blue there we've got the graph of x squared plus 1, and you can see that it is exactly the same as the x squared graph, just 1 higher. And as I increase the value of a, you can see the blue graph gets higher and higher and higher. So if a is 6, we can now see it's crossing through the y-axis at the coordinate 0, 6 now, rather than at 0, 0. Let's make a bit bigger. Let's make a become 10. And we can now see that the blue graph has gone up 10 squares. It's now got its turning point at 0, 10, rather than 0, 0. What about if I make a smaller again? We can see the graph's going down in the y direction. If I make a negative, you can now see it's gone down in the y direction by 3 squares if a is negative 3. So this change of having f of x and then the plus a on the outside, that's affecting the y coordinates, and I'm either going to move it up if it's positive or down if it's negative. Second graph transformation, we're now going to look at same original graph, x squared. You can see here that I've got the plus a inside the brackets now. So this is like me doing f of x plus a. So let's see what effect that has on the graph. So if a is 1, we can see that the blue graph has now got its turning point at -1, 0 instead of 0, 0. And as I increase the value of a, if a was 2, we can see it's now gone 2 squares in the negative x direction. Or if a was 10, it's gone 10 squares in the negative x direction. What about if a was negative? If a is negative, we can now see it's going in the positive x direction. When a is -2, the turning point is now at +2. If I make a become -5, you can see it's gone 5 squares in the positive x direction. So what effect does this plus a on the inside do? Well, it's going to affect the x direction. It's either going to go right or left. It's going to go right if a is negative, and it's going to go left if a is positive, which is the opposite way round to what you'd usually expect. Next graph transformation. We're now going to switch things up a little bit. We're going to look at the sine graph now rather than the x squared graph. And this time, the transformation we're focusing on is if I have an a at the front, if I'm multiplying by a, this is my f of x function. So this is like me doing a f of x. And so what effect does that have on the graph? Well, if a is 2, it looks like this. If a is 3, it looks like this. If a is 4, it looks like this. If a is 10, it looks like this. Let's talk about what's actually happening here. Hopefully you can see that it's a stretch in the y direction. But let's talk about it in a little bit more detail. So where we previously had this coordinate here, which was 91, we've now got the coordinate 92. You can see that the y coordinate has been times by 2 because of the 2 here. Whereas where the y coordinate was 0, here, 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 well, timesing that by 2 doesn't do anything. So that stays exactly where it is. 0 times 2 is still 0. The coordinate that was here, which was which is 270 minus 1, that is now at 270 minus 2. So again, we've just multiplied the y coordinate by 2. So it's this transformation, it's a enlargement, it's a stretch in the scale in the y direction by scale factor a. What about if a was less than 1? What would happen there? Well, then I'm going to be multiplying by something that's less than 1, so it's going to get smaller. It's going to get more squashed in. Here I've got the scale factor set to 0.5, so we can see here that it's the maximum point here is at 0.5 instead of 91. We've halved the y coordinates here. Next graph transformation. Now we're looking at the a being on the inside of the brackets. So this is my f of x function again here, and now I've got the a on the inside, so f of ax. I'm going to think about what that does to the graph. So a is set to 2, and it looks like this. We can see that it's been squashed in the x direction. The point that was previously here at 91, that's been squashed in to be here at 45.1. The point that was here at 180.0 on the original red graph is now here at 90.0 on the blue graph. So what's happened here is it's squashed in the x direction. We've divided all of the x coordinates by 2. It's an enlargement by scale factor 1/2 because I've divided by 2 in the x direction. So if I make a bigger, it's squashing in more and more and more because I'm dividing by the x coordinates by bigger and bigger numbers. If a is 10 there, I'm dividing all of the x coordinates by 10, so that's why it's squashed in so much. If I make a less than 1, so for example, if I make a 1/2, we can now see that it's stretched out in the x direction. The coordinate that was previously here at 91 is now here at 181. It's doubled because that's the same thing as dividing by 0.5. If I divide by 0.5, that's the same thing as dividing by 1/2, which is the same thing as timesing by 2. The x coordinates timesed by 2. It's stretched out by a scale factor of 2 in the x direction. Right, two more transformations to talk about, then we'll summarise all of this. In this case, I've got the f of x function, which is the x squared plus 4x, and we can see here that I've just put a negative in front of it. So this is like me doing minus f of x. What effect is that going to have on the graph? There it is in blue. Hopefully you can see that's a reflection in the x-axis. The minimum point I had before, the turning point before, was -2, -4. It's now -2 plus 4. Why has that happened? Well, what this negative has done is it's multiplied the y coordinates by -1. This is almost like me having a -1 f of x, and as we saw a moment ago, that affected the y coordinates and meant I times them by -1. So where I had all of these values here, where y was previously negative, I've just multiplied them, so now the y is positive. Whereas before, all of these values here that were positive on the original graph, I've just times them by -1, so they've all become negative on the transformed graph. So that minus in front of the function there is a reflection in the x-axis. Now we're having a look at what happens if the minus is inside the brackets. That's a reflection in the y-axis. The turning point here at -2, -4 is now at +2, -4. The root here that was at -40 is now at +40 over there. The reason for this, as we saw a few moments ago, the minus on the inside here is similar to me doing this, which is similar to me having -1 times x on the inside here, which, thinking back to the f of ax transformation, this means I'm going to be dividing the x coordinates by -1. So if I'm dividing the x coordinates by -1, I'm basically just changing their sign. If they were negative, I'm now making them positive. If they were positive before, this x coordinate here is 1, I'm now making it negative. So that is why this transformation is a reflection in the y-axis. So, summarising all of those transformations, you can think of them the six different transformations like that, or a slightly quicker way to think about it is, if I've got my function y equals f of x, if the change, the extra number that we're adding in, if that's outside the brackets, it affects the y coordinates, and we just do the normal operation. If it says to add 5, I'm going to add 5. If it says to subtract 10, I'm going to subtract 10 from all the y coordinates. If it says to multiply by 4, I'm going to multiply the y coordinates by 4. However, if the change is on the inside of the function, that's going to affect the x coordinates, and I'm going to do the opposite of what it tells me to do. If it says x plus 5, I'm going to subtract 5 from the x coordinates. If it says 2x, I'm going to divide the x coordinates by 2, and so on. Right, let's have a look at 3 examples of exam questions where we're using these graph transformations. So in figure 1, we've been given a function there. It hasn't specified what the function is, and it doesn't really matter. We can see that it's got roots at 2 and 4, and it's got a turning point there at 3 minus 2. And it's asked me to draw the graph of minus f of x. Now that minus at the front there, I know that's going to affect the y coordinates. It's going to take the y coordinates and make them change sign. If they're negative, it's going to become positive. So this part of the graph is going to become positive, whereas this part of the graph and this part of the graph are going to become negative. The roots won't be affected at all because they are at 0 in the first place. So my roots are still going to be 2 and 4. My turning point is now going to be at 3 plus 2. And so it's now going to look something like this. It's basically a reflection in the x-axis. Second part of this question asks me to draw f of 2x. Now that 2 is on the inside of the function. So I know that affects the x coordinates. And I'm going to do the opposite. I'm going to divide the x coordinates by 2. So my roots are going to be divided by 2. So we're now going to be at 1 and 2 instead of 2 and 4. The turning point did have an x coordinate of 3. So I'm going to divide that by 2, and it's now going to be at 1.5. The y coordinate will not change at all. We'll still be at -2. So the graph is going to look something like this. It's just squashed in by a scale factor of 2 in the x direction. Different question, figure 1 is shown there. We can see it's got a y-intercept of 3, it's got a repeated root at 1 and another root at 4. And we're asked to draw the graph of f of x plus 1. That plus 1 being on the inside of the function, so I know I'm going to do the opposite. So I'm going to subtract 1 from all of the x coordinates. So the roots are now going to be at 0 and 3. 0 and 3. And so it's now going to look something like this. It's going to come down to 0, up, and then back down for 3. The whole graph has just moved 1 square in the negative x direction because I've just done the opposite. Second part of this question says I need to draw 2f of x. The 2 is on the outside here, so I'm going to multiply all of the y coordinates by 2. So the new y-intercept will be at 0, 6. The roots won't be affected at all. They'll still be at 1 and 4. Because the y coordinates are 0 at those, and timesing those by 2 will still be at 0. So the new graph is going to look something like this, and down, touch there. The turning point would be higher because the y coordinate at the turning point here, whatever that is, that would move, that would get twice as high as well. So I just need to make sure that I draw my turning point high enough. And there we go. Oh, that looks a bit bad there, but let's neaten that up. There we go. It's just a stretch by a scale factor of 2 in the y direction. Last examples. Here we've got a random function being shown here. We've been told that the roots are at -2. At the origin, I don't know what these roots are here. I know it's got these coordinates given to me as well. And I need to draw the transformation of f of x plus 4. So that plus 4 is going to add 4 to all of the y coordinates. So this whole graph is going to shift up 4 squares in the y direction. So the origin here is going to move up 4 squares to be at 4 here. The point 1, 2 is now going to be at 1, 6. The point 3 minus 4, if I add 4 to the y coordinate, that's now going to be at 3, 0. Because minus 4 plus 4 will be 0. So this part of the graph will look like that. this is this part of the graph just moved up 4 squares. This will be up here like this. Again, it's just moved up 4 squares. The turning point, or this, I don't know this coordinate here, but I'll just stop there roughly. I don't know exactly where that is, so I'll leave that there. And the point that was here at -2, 0 is now going to be here at -2, 4. And there we go. The whole graph has just shifted up 4 squares in the y direction. And final example for this video, we've got this minus on the inside there, so I know that that is going to affect the x coordinates. I'm going to divide all the x coordinates by -1, which is just going to be a reflection in the reflection in the y-axis. This part of the graph here will stay exactly where it is. This part of the graph here is going to reflect over and be like this. So let me mark that bit in. So going down to its vertex there and then back up. This point here is the 2 from over there. So I've just reflected that in the y-axis to be there. And I'm going to do the same on the other side. I'm going to reflect this part of the graph over to be like that. Where this is now the point -1, 2. It's this point that's got reflected over. I've divided the x coordinates by -1. And this point here is going to be the coordinate -3, -4, because again, I've just reflected that point over in the y-axis. I've just divided the 3 by -1. And there we go. So these are the 6 graph transformations and the effects that they have on various types of graph. This is the shortcut way of remembering how to apply it quickly and easily.